Hello everybody, welcome to the A-level Chemistry Tutor channel. Today we'll be going through the basic principles of atomic structure and looking into how mass spectrometers work, including methods of electrospray ionization and electron impact. Before we start the topic, it is extremely vital, in order to be able to understand the requirements listed, as the overall understanding of the video will be loose and confusing without the prior knowledge. Also keep in mind that the early development of the atomic model is not a compulsory requirement from the AQA exam board. However, it's good to be able to bring this knowledge in order to bring greater interest to the atomic model. Now, as you can see, this image may seem quite familiar to you from your studies in GCSE chemistry, which shows a representation of Bohr's atomic model. The protons and neutrons in the nucleus of the atom are defined as nucleons, as these are the subatomic particles which are located in the nucleus. Typically, we would find the number of protons being equal to the number of electrons, as atoms are considered to be electrically neutral if it's not an ion. In any element, the atomic number shows the number of protons an atom has in its nucleus, and the mass number shows the number of protons and neutrons added together. We can also calculate the number of neutrons by subtracting the mass number by the atomic number. Now again, from your previous studies in GCSE chemistry, you should be able to understand the definition of an isotope, where in its simplest form, an isotope is a different form of the same element. An isotope of an element always maintains the same number of protons, but always has a different number of neutrons, so it has a different mass, as we also assume that if an isotope is electrically neutral, the number of protons in an isotope would be the same as the number of electrons. As all isotopes also have the same number of electrons, they must be chemically identical, as they have the same electron configuration. You are also expected to know specifically about the naturally occurring isotopes of chlorine. With chlorine, the element consists of two naturally occurring isotopes, which are chlorine-35 and chlorine-37. If we look at a mass spectrum of a sample of chlorine, which we will view later, you would see two peaks where one of them is 3 times higher than the other. This is because the naturally occurring isotopes of chlorine come in a 3:1 ratio, where the chlorine-35 peak is 3 times higher than the chlorine-37 peak. Now that we have gone through the theory of isotopes, it's important to understand how we can identify isotopes from unknown samples using mass spectrometry. A mass spectrometer is simply able to identify the mass of an unknown sample and use this information to identify the sample. There are two methods in which we can perform this. We could use electron impact, where the sample is first vaporized into a gas and injected through a hypodermic needle into the ionization area. An electron gun, or a hot wire filament, is then able to fire highly energized electrons to the sample and knock an electron off, which forms a +1 ion. This ion is then accelerated towards the negatively charged plate and enters the drift region, where the ions travel at respective velocities corresponding to their mass, where an ion with a greater mass would travel slower than an ion with a lower mass, and vice versa. The ion is then able to gain an electron at the detector and form a current which is proportional to the abundance of the isotope. The method in electrospray ionization is identical, despite the fact that this sample is dissolved into a volatile substance and then it becomes injected through the hypodermic needle. I understand that this may be quite a lot to take in, so it is suggested that you go over this slide until it is comprehensible. As I have mentioned earlier, after all the ions have been able to gain an electron to form a current and hence form a peak, we can observe the peaks formed from the sample by looking at the connected monitor, where on the x-axis the atomic number of the isotopes are displayed and on the y-axis the percentage abundance is displayed. In this example, it shows the signal intensity, which is also known as the percentage abundance. Now, from looking at the values of the percentage abundance, we can determine the relative atomic mass of the substance by finding the sum of the product of the abundance and atomic mass and divided by the total abundance, which you can see demonstrated in the notes. When we talk about the relative atomic mass of a substance, we relate to how the relative atomic mass is the average mass of an atom compared with 1/12 of the mass of one carbon-12 atom. The reason why we use carbon instead of any other element is because the mass of carbon-12 is exactly 12. This is the same with the relative molecular mass, where we use molecules instead of elements. Thank you for watching this video. Please give it a like and subscribe for more future content. And don't forget to share the video with your friends. If you have any queries with this video, be sure to leave a comment and I'll get back to you as soon as possible. And as always, I'll see you on the next one.